Welcome to Math TV with Professor V. In this video, we're going to learn how to solve radical equations. This is video lecture number 37 if you're following along in the intermediate algebra video lecture series. So first, we're just going to look at an example and then I'll give you guys a procedure to follow, okay? So say you're trying to solve the following equation, the square root of x plus 2 equals 5. So what makes this a radical equation is the fact that the variable is underneath a radical. And so we have to basically peel away layer by layer to get the variable all by itself to solve for x. And since the radical is all by itself on one side of the equation, what I can do is go ahead and square both sides. So I'm undoing the square root, right? And now on the left-hand side, I'm going to just be left with x plus 2, and then 5 squared is 25. And then now this equation is pretty straightforward. Subtract 2 from both sides, and we get that x is equal to 23. Do we trust it? Well, we could always check just to make sure, right? So let's check. In the original equation, is the square root of, instead of x, I'm going to put 23 plus 2. Does that equal 5? Sure thing. Square root of 25 equals 5, so we're good to go. So then I would say, yeah, put your solution, which was 23, in your solution set. Okay, so we're going to now solve radical equations. Some have square roots, some have cube roots, some have fourth roots, okay? The index can change. And in order to solve radical equations, we're going to apply the principle of powers. So what it tells us is that if a is equal to b, then a to the n is equal to b to the n. So basically, if you have an equation, you can raise both sides of the equation to the same power and preserve equality. However, you do have to be careful because you potentially could have extraneous or extra solutions when you're solving this equation here, okay? And so here's basically the guideline to follow. If n is even, so if you raise both sides of the equation to an even exponent, then you must check your solution or solutions. Sometimes you get more than one. How exciting. In the original equation. Okay, so basically if you square both sides, if you raise both sides to the 4th power, to the 6th power, etc., you gotta check your answers in the original equation. Sometimes you'll have extraneous solutions that don't satisfy the original. If you raise both sides to an odd power, like you cube both sides, you don't have to worry about it. Okay, but if you're the especially paranoid type of student, then just check them all, whatever, you know? Okay, so let's start working out some examples. And general guideline I want you guys to keep in mind is always try to isolate the radical first. So get the radical all by itself and then raise both sides to whatever the index is, okay? Good. So here we have example A. We're going to start off nice and gentle. Don't worry. Square root of 9 minus y equals 4. So radical is already isolated. I'm going to go ahead and square both sides. And so now on the left-hand side, I just have 9 minus y, and this is equal to 16. Very good. Now, to isolate y, I'll subtract 9 over to the other side. So negative y equals 9. Excuse me, that's not what I meant to put. 16 minus 9 is 7, which means that y equals negative 7. Okay, now remember, I squared both sides. I raised both sides to the 2nd power. 2 is an even number. So we have to check this answer, this solution of negative 7 in the original before we can say that we've finished the problem, okay? So here we go, checking time. Is the square root of 9 minus negative 7, put a question mark right now, does that equal 4? So is the square root of 9 plus 7, does that equal 4? Certainly, square root of 16 equals 4. So we're good to go. So then that's why I especially like to put a solution set, because it helps me stop and think and take that one extra step to remember that I'm not done when I just hit y equals -7. No, I got to check that solution before I can put it in the solution set. Okay, good. Let's look at another. Here we've got square root of x plus 3 minus 12 equals 0. So it's not time to square both sides yet, because what do we need to do first? Very good. Isolate the radical. Get that rad x plus 3 all by itself. So we're just going to add 12 to both sides. Move that 12 over. So now we have rad x plus 3 equals 12. Oh, now we can go along and square both sides. So lovely. So now we're going to have x plus 3 equals 144. Perfect. Last step, just subtract 3, so x equals 141. Okay, do I need to check this one? Yes, absolutely. We squared both sides, so we raised both sides to an even exponent. We need to check. So we've got square root of 141 plus 3, always check in the original, minus 12. Does that equal 0? So does the square root of 144 minus 12 equal 0? Yes, it does. 12 minus 12 is 0. So we're good to go. So then I would put 141 in my solution set. Very nice. Okay, how are you guys doing so far? Very good. Let's move on to example C. Radical 4x plus 5 minus 2 equals 2x minus 7. Okay, so we got to get that radical all by itself first. So let me add 2 to both sides. So now we're going to have radical 4x plus 5 equals 2x minus 5. Yeah? Good. Okay, now let's square both sides. So the left-hand side, that's pretty straightforward, right? We're going to be left with 4x plus 5. But be careful, 2x minus 5 squared, you have to square that entire quantity, right? So if you need to write it out twice, so you don't forget that middle term that's there, feel free, okay? If you remember how to square a binomial, then you can save yourself a little bit of time, which is what I like to do. I don't usually write it out twice, but you know what? If you're sort of the careless kind of student, they're out there, it's okay. Just own it and then write it out twice. That way you don't forget, okay? So when we take 2x minus 5 and square it, we're going to have 4x squared. The middle term, if you just need a little review, you multiply these two terms by each other. 2x times 5, that's 10x, and then you double it. So minus 20x plus 25. That's what you would get after you FOIL, okay? Very good. Now what do we do from here? The second you see that, ooh, there's a quadratic term, right? It's x squared. Our equation's quadratic, then we got to set it equal to 0. Okay, change your strategy for solving equations. When you only have a linear equation, x to the first, you get the variable by itself on one side, constants on the other. But if it's x squared, x cubed, x to the fourth, etc., 99% of the time, set it equal to 0. Okay, so I'm just going to move everything over to the right. So we've got 4x squared minus 24x plus 20 is all equal to 0. And before I try to factor, everything divides by 4, doesn't it? Oh, how fabulous. Okay, so 0 divided by anything except 0 is 0, so that's good. And then we'll have x squared minus 6x plus 5. Can you factor that? Your factor's so nice. X minus 5, x minus 1. Fabulous. So using the zero product property, we get two solutions, two possible solutions, x equals 5 and x equals 1. Now I need to check both of these in the original, okay? Not after you've squared. They will satisfy the squared equation. What they may not satisfy is the original. So 4x plus 5, rad 4x plus 5 minus 2 equals 2x minus 7. I'm going to check them in there one at a time. So let's start off by checking x equals 5. Let's see. So radical 4 times 5 plus 5 minus 2. Does that equal 2 times 5 minus 7? Let's see. So that's rad 25 minus 2. Does that equal 10 minus 7? Rad 25, that's 5 minus 2. Yep, that equals 3. So we're good. Hooray! And then x equals 1, I need to check as well. Okay. So let's see here. Square root of 4 times 1 plus 5 minus 2. Does that equal 2 times 1 minus 7? Let's see. Square root of 9 minus 2. Does that equal 2 minus 7? No. 3 minus 2, that doesn't equal negative 5. No way. So what does that mean? You didn't do anything wrong. It just means x equals 1 is an extraneous solution. So it's a solution of the equation that we squared, but not the original. So it won't go in the solution set. It's not part of your final answer. Okay, so only put x equals 5. That's the only one that checked out. Okay, and it's not your fault. Like there's no way around it. It's just part of what happens when you square both sides of an equation. You essentially lose information because you're squaring both sides. So you're losing some information about if things were positive or negative to begin with. So you just got to check it. Okay, it's not the end of the world. All right, moving on to example D. Cube root of 6x plus 9 plus 5 equals 2. Ooh, we haven't done a cube root yet. How exciting. So again, isolate the radical. So I'm going to subtract 5 from both sides. Cube root of 6x plus 9 is equal to negative 3. And then to get rid of the radical, you just raise both sides of the equation to whatever the index is. So the index here is a 3. Remember, the index is this little baby number right here. So I'm going to cube both sides. So now on the left, we just have 6x plus 9. And then negative 3 cubed is negative 3 times negative 3 times negative 3. So that's negative 27. Okay, this looks harmless. I only have x to the first power, so I'm just going to keep that 6x on the left, subtract 9, divide by 6, so x equals negative 6. Do I need to check? No, because I raised both sides to an odd power, so I don't have to worry that this might be an extraneous solution. But like I said in the beginning, if you're just especially paranoid and nervous, then just check them all. It's just the ones with the odd indices will always work out, okay? Unless you did something wrong. Certainly that would cause problems. Okay, I got a couple more for you. How are we all doing? All right, example E, we have 2 square root of x plus 4 equals x plus 1. Now, I did say the first step is to isolate the radical, but I'm not too keen on doing it here because to get this radical by itself, I would need to divide by 2, and then I'd have fractions over here, and my next step is to square both sides, and I'd really rather not be squaring a bunch of fractions if I can help it, you know? So what I'm going to do is ever so cautiously square both sides the way it's written right now. Yes, so proceed with caution. When you square the left-hand side, you have to square the 2, so it's going to become a 4, and then the rad x plus 4 just becomes x plus 4. Did you see that? Attention. This was a dangerous move, but I think it's for the best. Equals. Also, don't be careless with that right-hand side. It's x plus 1 times x plus 1, which is going to be x squared plus 2x plus 1. Don't forget that 2x. We talked about it earlier. Okay. I can see the equation's quadratic, so I'm going to want to set everything equal to 0. Yes. All right, I just distributed on the left, and so we're going to have x squared minus 2x minus 15 equals 0. Does this factor? Why, yes. X minus 5 times x plus 3 equals 0. So we have two solutions to check. X equals 5 and x equals negative 3. Let's move this over here. Okay, so let's check. 2 times the square root of 5 plus 4, does that equal 5 plus 1? So 2 times rad 9, does that equal 6? Yeah, 2 times 3 is 6. Great. What about negative 3? So 2 times square root of negative 3 plus 4, does that equal negative 3 plus 1? I can already tell it won't work because I'm going to get a negative number here, and I can tell the left-hand side's not going to be negative, right? 2 times rad 1, that doesn't equal negative 2. 2 doesn't equal negative 2. Get real. So that means this one's not going to work. X equals negative 3 is not going to go in the solution set. So the only answer we're going to report for this one is 5. Sometimes both will work, okay? So don't think you're always going to throw somebody away. Sometimes none will work, in which case you'll have no solution. So just be ready. Anything can happen, people. Okay, here we go, another one. X to the 1/4 minus 2 equals 1. Remember, x to the 1/4 is the same as the 4th root of x, okay? So let's isolate that radical. I'm just going to leave it as x to the 1/4 though. You really got to get used to it, especially if you're going to take calculus. Oh my goodness. You rewrite your radicals as rational exponents all the time. Good. I'm going to raise both sides to what power? The 4th. Bravo. Okay. So now I'm just going to have x on the left-hand side. 3 to the 4th is 3 times 3 times 3 times 3. Or you could think of just square 3 twice in a row. So if you square 3, it becomes 9, and then square it again, now it's 81. Okay, good. We got to check. Why do we got to check? Because we raised both sides to an even number, 4. So this is one we got to check. Is 81 to the 1/4 minus 2, does that equal 1? 81 to the 1/4, that's the 4th root of 81, that's 3 minus 2, yep, that equals 1. So I can put my solution of 81 in the solution set with a clean conscience. How fabulous. Okay. I got 2 more. Spice level is increasing because if you'll notice, now we have more than one radical in the equation. So what to do, you basically have to just knock them out one at a time. You can't square both sides right now because you're just going to make your life worse. You're still going to have more than one radical in the equation. So you got to isolate one radical, square both sides, and then repeat the process. I like to get the uglier one taken care of first. So what's uglier to me? The one that has more stuff underneath, the one that looks messier. So rad 4x minus 7 equals 1 plus rad 2x. And then now I'm going to square both sides. Okay, so look at what we have. So we have 4x minus 7 equals... Okay, if you're a bit of a disaster, I'll write this out twice, just so you can have a little bit of practice multiplying these out. But if you need to review multiplying radicals, I'll link a video right here. Okay, 4x minus 7 equals, no meltdowns, you can handle this. 1 times 1, that's 1, plus, this is going to be rad 2x plus another rad 2x. And then the last product here, rad 2x times rad 2x is just 2x, right? No more radical. Okay, so look what we've done. 4x minus 7 equals 1 plus 2 rad 2x plus 2x. Stop here and look at what the progress that you've made and say, have I made my life better or worse? Am I headed in the right direction? Well, how many radicals do you see? Just 1. Oh, fabulous. We started with 2, so we're getting somewhere. Do you know what I mean? Yes. Now we're going to get this radical all by itself as much as possible. So let's subtract 1 and subtract 2x. So now I'm going to have 2x minus 8 equals 2 rad 2x. This time I will divide by 2, unlike example E. Why? Because on the left-hand side, both those terms divide evenly by 2 and I won't have fractions. So it'll be nice. So we've got x minus 4 equals rad 2x. Beautiful. Let's square both sides. We're making such progress. So what do we have now? X squared minus 8x. Yep, don't forget that minus 8x plus 16 equals 2x. Set it to 0 because it's quadratic. So x squared minus 10x plus 16 equals 0. Does it factor? Pretty much all of these will. X minus 8, x minus 2 is 0. So we have two solutions to check now. X equals 8 and x equals 2. And where do we check them? Correct, in the original. So the original was rad 4x minus 7 minus rad 2x equals 1. So let's check them one at a time. Let's check x equals 8. So does rad 4 times 8, that's 32, minus 7, minus rad 2 times 8, 16. Does that equal 1? So square root of 25 minus 4 equal 1. Yes, it does. Cool. Now let's check x equals 2. So here we go. Square root 4 times 2, that's 8 minus 7 minus square root of 2 times 2, that's 4. Does that equal 1? So 8 minus 7, that's 1. Square root of 1 is 1. 1 minus 2, no, that doesn't equal 1. That equals negative 1. So this solution is extraneous. Let's just cross everything out that had to do with that 2 so we don't accidentally report it. So the only answer that goes in the solution set is 8. 8 is so great. Okay. Last one, are you ready? It's perhaps the spiciest, yes. So, if f of x equals the square root of 2x plus 1 minus the square root of x plus 4, find any x for which f of x equals 3. So basically, to start the problem, you have to write the equation and replace f of x with 3. So you're going to set that expression, that function, rad 2x plus 1 minus rad x plus 4. You're going to set it equal to 3. Okay. And then, like we did last time, isolate one radical, square both sides, clean it up, and then repeat the process. Isolate the other radical. Okay? I know this is a little challenging, but why don't you guys pause the video, give it a try on your own. Let's see how far you can get. Okay, how'd you do? Here we go. So I'm going to move over the rad x plus 4 because it's already negative. I feel like it's wanting to be added over to the other side. Don't you? Okay, you could have isolated either one though first. It won't matter. Square both sides. So now on the left, we've got 2x plus 1. On the right, squaring 3 gives us 9. 3 times rad x plus 4 times 2 is 6 rad x plus 4. And then if I square rad x plus 4, I just get x plus 4. Yeah? Did you do this part okay? If not, check your work again. Maybe you need to write out this quantity twice in FOIL if you messed this up. That's okay. 2x plus 1 equals, let's combine our like terms. Yeah, 9 and 4. So now we've got 13 plus x plus 6 rad x plus 4. I'm going to get that radical all by itself. So I'm going to subtract 13 and subtract x. So now I have x minus 12 equals 6 rad x plus 4. Do I want to divide by this 6? No, because I don't want to have 1/6 x when I'm squaring both sides. Gross. The 12 would divide evenly, but let's just keep it fraction free. Sound good? So we'll square both sides, but we just have to have our wits about us and remember to square the 6 on the right-hand side. Okay, so this is going to be x squared minus 24x. Don't forget the 24x equals, square the 6, it's 36. And then squaring rad x plus 4 just gives us x plus 4. Good? Yay. Okay, let's clean things up. So x squared minus 24x plus 144 equals 36x plus 36 times 4 is 144 as well. Wow, wow, wow. So if I set everything equal to 0, 144 is just gone. Look at that. Oh, and then subtract 36x. We're going to have x squared minus 60x equals 0. You know what's so funny? My students usually get nervous when they see that there's only 2 terms and they have to factor, but for some reason it's actually easier than our normal factoring for trinomials. You just take out the greatest common factor, which in this case is an x. So you just got x times x minus 60 equals 0. See? Oh, that wasn't so bad. And then using the zero product property, when you have that little x all by its lonesome, that means x equals 0 is a solution. And then x minus 60 means x equals 60 is a solution. Again, though, we have to check these, yeah? We have to check them in the original. Okay, so let's check. Let me write the original. It was rad 2x plus 1 minus rad x plus 4 equals 3. So let's check x equals 0 first. So is the square root of 2 times 0 plus 1 minus the square root of 4. Does that equal 3? So square root of 1, that's 1, minus 2. No, that's not 3. Oh no. Okay, let's check 60. And like I said, sometimes you get no solution, so just deal. Okay, square root of 2 times 60 plus 1 minus the square root of 60 plus 4, that's 64. Does that equal 3? 2 times 60 plus 1, that's 121. Ooh, yes, right? Square root of 121, that's 11. Minus 8, that equals 3. Hooray! Okay, so 60 goes in the solution set. Oh, let me cross out everything that has to do with 0. Let's just put a nice solution set down here. The solution is 60. Okay, so that concludes the video. Give it a thumbs up if you enjoyed it. Don't forget to subscribe to my channel and stay tuned. We've got more algebra videos coming your way. If you see that little join button, you can join this channel to get access to exclusive perks. And I appreciate all your support so much. Take care, guys.